this video if you get stuck. All right, here we go. It's two parts. Part one's going to have us doing a hypothesis test. Part two is going to have us create a confidence interval. The situation is Leroy making 40% of his free throws last basketball season. He practiced all summer and has made 25 of his 40 attempts this season. The question is, did his practice help? We're going to go at this problem with a four-step process. So here we go. Step one. Like always, we're going to establish our population, our parameter, set up a null hypothesis and alternative, as well as a significance level which we need to test against. So the population, since we're talking about free throws, is all of his free throw attempts. The parameter, what are we interested in? We're interested in the percentage of his accuracy. So the true proportion, that's big P, true proportion, population proportion, true proportion of successes. Our null hypothesis. Null hypothesis is that the practice didn't help. All summer long he practiced his free throws. It didn't help. Nothing's changed. The proportion is still 40%, still 0.40. The alternative hypothesis is that his practice did help, that the proportion is greater than 40%. And what are we testing against? We're going to test against a significance level as prompted in the problem of 0.01. We want to be absolutely certain that his free throw has improved, and so we're going to set ourselves a very high standard to show change. Step one. Step two. Step two is our conditions, and we know from previous videos that the conditions in a proportion problem, while the same, are tweaked a little bit as compared to that of a mean problem. So we still need to establish whether it's a simple random sample or not, if we have normality, and if this is independent. So unfortunately, these 40 attempts that Leroy just made are from the first 8 games that they played in the season. So that's not a simple random sample, so we have to assume that, that it is. Normality, we've learned in previous videos, is proven differently than for a mean. It's not the central limit anymore, and we don't know that the percentages are normally distributed. We have to show it by saying we have a large enough sample size. So is the sample times my null hypothesis greater than 10? And at the same time, is my sample size times the complement of my null hypothesis also greater than 10? Let's go ahead and check that. 40 times my null hypothesis of 40%? Well, yeah, that's 16, so we are good to go there. And if that one works, the other one's going to work as well. 40 times the complement of 60% is equal to 24, so both of those satisfy our normal condition. Independence, all free throws are greater than 10 times my sample. Is Leroy going to take more than 400 free throws over the course of his basketball career? I would say sure. All right, step two. Calculation step. In this step, we are going to show, hopefully, a significance value that is low enough to disprove our null hypothesis. Z is equal to my sample proportion minus my hypothesized proportion divided by the standard deviation of my estimate. The standard deviation of my estimate means P sub naught, 1 minus P sub naught. Again, these are my hypothesized values, this 0.4, the 40% over my sample size. Let's drop in our numbers, then go to our calculator. 25 of 40, so that's my x, the 25. My sample size, n, is my 40. That's 0.625. So my sample of 0.625 minus my hypothesized value of 0.4 divided by the square root of 0.4 times 0.6 over my sample size of 40, and go into my TI calculator. Again, in order to do this, you're going to hit the stat button. You're going to go over to tests, and then you're going to go down to a one proportion z-test. So stats, over to tests, down to a one proportion z-test. Here I'm going to put in my null hypothesis, that 0.4, my observed successes, 25, my sample size is 40. We're seeing if he improves, so this is the greater than P sub naught at the very back end, and we're going to calculate, and here's the values we get. Z is equal to 2.9. That is a long, long ways away from the mean. That's good. That's hard to do. P-value is going to be equal to 0.0018. So I'm going to round that to 0.002. So when that's all said and done, we're going to step on over to our final phase of this problem. Step 4. Step 4 is our conclusion with context. We're needing three different things. We need evidence. We need to make a choice to reject or fail to reject, and then we have to put that choice into the context of the problem. So here's our evidence. Our p-value of 0.002 is indeed less than alpha at 0.01. Even though our alpha is super small, we have exceeded that threshold and have a p-value less than that, which means our choice is pretty much made for us. We reject the null hypothesis, which means we can say it seems that his accuracy has improved. All right, nice work. All that practice has paid off. So it seems like his accuracy has improved. The question remains, though, how much has his accuracy improved? That's where part 2 of this problem comes in. We're going to conduct a confidence interval calculation and figure out where Leroy's free throw accuracy percentage actually is. All right, this is part 2 of the problem. Here we go. Problem actually asks us to construct and interpret a 90% confidence interval for the proportion of free throws Leroy will make this season. So in a previous video, I reminded you of the confidence interval formula, but here it is again. All it asks for us to do is construct and interpret. That means step 3 and step 4 of a confidence interval. So step 3 of a confidence interval, the calculation, is going to have us say p hat plus or minus z star, that special number that gives us the particular zone of interest that we're looking for, times the standard deviation of my sample. That's p hat times its complement over the sample size. Let's drop in our values and then use our calculator to solve for us. P hat, that's 25 divided by 40.625, plus or minus. Z star, for a 90% confidence interval, can be found on table C. I'm going to go all the way to the bottom, look at my confidence level for a 90% confidence interval. That is 1.645. Saying that if we are 1.645 standard deviations up and down from the mean, we will capture 90% of the observations. Dropping in my values for the standard deviation, 0.625 times 0.375 over my sample size of 40. I'm going to let the calculator do the work for me on this one because order of operations really easy to mess up if you don't put your parentheses in the right spot. In order to do that on a TI, you're going to hit the stat button. You're going to go over to tests and then down to a 1 proportion z interval. Your values actually should be in your calculator still from when you conducted a hypothesis test. And so once we get there, 1 proportion z-int, we see that the x is already 25, the n is already 40. Confidence level defaults to 0.95 for me, so I'm going to set that to 0.90, and I will calculate. And here is our confidence level. It's 0.499, so I'm going to round that to 0.50. And it's 0.7509, so I'm going to round that to 0.75. The problem asked me also to interpret this, so that means I need to do step 4 and put these numbers into the context of the problem. So that's step 4 for our confidence interval problem, which is the conclusion. Conclusion in context for confidence intervals, as you may remember, starts out with I am blank % confident. And in this particular case, we're creating a 90% confidence interval, so I am 90% confident that the true, what are we talking about? We're talking about proportions, not means, so I'm going to say the true proportion of the context here. We're looking for made free throws is between, here we have 50 and 75%. So it looks like Leroy has upped his game and is now making between 50 and 75% of his free throws. That's still a pretty broad range. In order to shrink this range, you get a more accurate read on his true free throw accuracy, we could do one of two things. You could either up your sample size, and that would shrink your range there, or you could decrease your confidence level. Decrease your confidence level also focuses in here, so that would give you more accurate results, but at the expense of being less confident. So there it is, all of practice problem 12.2.1. Thanks.